Today we're going to be looking at dot products, okay, more specifically the scalar product between vectors in 2 dimensions. So let's first start off with A dot producted with vector B. What does that even mean? Okay, so what this means is we take vector A, so 1, negative 4, and we dot it with vector B, 2, 3. To work out the value of this dot product, what we have to do is multiply the I components together, the horizontal components, and then add it with the j components being multiplied, or the vertical components being multiplied. So what do we get when we do this? Well, 1 times 2 is just 2, and minus 4 times 3 is minus 12. So if we work this out, we evaluate it to minus 10. So the dot product is equal to minus 10. What does this number mean? It'll make sense in a little while. So let us now continue. What is vector B dotted with itself? Well, vector B is 2, 3. Dotted with itself, that's 2, 3. So what do we get? Okay, so we do 2 times 2, that's 4. Plus 3 times 3, which is 9, which gives us 13. So that is the dot product for this vector here, or for these two vectors dotted together. Next one, C dot C. Okay, and I want you to recognize a pattern between these two. You can also say, okay, if we work out what the magnitude of B is, okay, and if you remember from my last video, to work out the magnitude of a vector, you simply do Pythagoras. Okay, so you can just do the square root of the I component squared plus the j component squared. And in this case, if we take the I component is 2, j component is 3, so I did that here. So this just works out to square root 13. And you notice that the dot product, okay, if we look at the dot product and the magnitude, okay, the dot product is simply the magnitude squared. So what that seems to imply is there is a relationship. And the relationship is that a vector dotted with itself is simply equal to the magnitude of that vector squared. Okay, so let's use that same logic with this part here in part 3. Let us first work out what is the magnitude of vector C. So to work out the magnitude of vector C, okay, what we can do is we can just do Pythagoras. So square root of minus 2 squared plus minus 2 squared. Okay, that'll give us square root of 4 plus 4. So that's the square root of 8. Okay, but we know that C dot C is just the magnitude of C squared. So we know that this is just equal to the square root of 8 squared, and the square root and the square cancel. So we just get 8. That is the dot product between these two. Let's have a look at the next one. Okay, the next one is what is B dot producted with C? Well, we can just do the I components times each other. So that would be minus 4. Minus 4, and then the j components times with each other. So that's minus 6. So we do minus 4 minus 6. That'll simply give us minus 10. Okay, and the last one, what is A plus B dotted with A plus C? Okay, so in this case, okay, we're just going to work out each vector on its own first. So let's work out what A plus B is. If we do A plus B, okay, what we get is 1 plus 2. Okay, the horizontal components added together is simply just 3. And then the vertical components added with each other, the j components, minus 4 plus 3, that's minus 1. Dot producted with whatever A plus C is. So what's A plus C? A plus C. Well, 1 plus negative 2, okay, 1 plus negative 2, that's just the same as 1 minus 2, which is equal to minus 1. So you put minus 1 here. And then minus 4, and then minus minus 2, so be very careful, minus 4, and then plus minus 2, that's minus 4 minus 2, which is equal to minus 6. So now let's dot product this together. To dot product this, we times the I components together, so that gives us minus 3. We times the j components together, that gives us 6. Add them together, we get 3. So this is the dot product of this vector sum here. So that's how you use dot products, or that's how you work out what a dot product is. And really quickly before I move on, what does this actually tell you? Well, these numbers here don't really have much of a significance, but there is one number in particular that has quite a lot of significance. And that's when the dot product, okay, when the dot product between two vectors, okay, when that's equal to 0. What this means is that vectors A, okay, and vectors B, okay, are parallel to each other. So if we ever get a situation where the dot product between two vectors equals to 0, we can show that they're parallel. And why is the reason for this? Well, there's actually a secondary definition for the dot product, which says the following. Okay, it says that the dot product between two vectors is equal to the magnitude of A times by the magnitude of B times by the cosine of the angle in between these two vectors. Okay, and I will derive this formula in a different video, but for now just know this formula is true. If the dot product between A and B was equal to 0, so if this was equal to 0, that means you would be left with this equation here. Now, it wouldn't really make much sense to deal with a vector with no magnitude. That's just like a point, right? So what is the angle between a point and a point? Well, that doesn't really make sense, right? So it can't make sense that for this to be 0 or for this to be 0. So obviously these two can't be 0. So that leaves us with cos of theta equals to 0. If cos of theta, the angle between the two vectors, is equal to 0, the only angle in the first quadrant which holds true, the smallest value, is theta equals to 90 degrees. So we've just shown that in order for the dot product to equal to 0, theta must be equal to 90 degrees. Okay, and that also means that thus in the process, A and B are perpendicular. Okay, so that's how the dot product can be used to show perpendicularity. Okay, now we have this question here. We have vector A dot producted with vector B. So we have it in this order here. So now what we're going to do is just dot product them. So 2, -1 dotted with 3, -2. So this is vector A, this is vector B. 2 times 3 is equal to 6. -1 times -2 is equal to +2. Add them together, you just get 8. So this is the dot product between the two vectors. Okay, so it's just equal to 8. Part B, or question 2. A dot C. So A dot C would be the same as 2, -1 dotted with vector C, which in this case is -1 and 3. And this would just be the same as 2 times -1, which is -2, and -1 times 3, which is -3. And that would just be equal to -5. So this is the value of the dot product here. And the last one is A dotted with the vector A plus B. It should say plus, not dot. Okay, so this is the last one. Pause the video and give this a shot yourself. Okay, so we do vector A. So vector A is 2, -1. And now we need to dot product it with whatever A plus B is. So let's work out what A plus B is. So A is 2, -1 plus the vector 3, -2. To dot product this, we add them together. So the I component and the I component would give us 5. J component added with the J component is -3. So 5 minus 3 is the vector A plus B. So 5 minus 3. So let us now dot product this. 2 times 5 is 10. -1 times -3 is 3, so plus 3. And this will give us 13. So that is the dot product of all three of these vectors here. Okay, this is our next question here. If magnitude of A is equal to 5 and the magnitude of vector B is equal to 6, and we are told the angle between these two vectors is 45 degrees, we need to work out the dot product between A and B. So if you recall, I did teach you a formula which was the following. Another way to represent the dot product between these two vectors is the magnitude of A times with the magnitude of B times with the cos of the angle in between them, which is theta. So in this case, we've been told the magnitude of A is 5, the magnitude of B is 6, and theta is 45 degrees. So if we just plug it into our equation, like such, 5 times 6 times the cosine of 45 degrees, then we can say this is the same as 30 times the square root 2 over 2, which is just 15 root 2. So this is the dot product for A dot B here. Similarly, we have this question here. If the magnitude of A and B is still 5 and 6 respectively, however, this time the angle between vectors A and B is 120 degrees, work out A dot B. So pause the video and give this a go yourself. Okay, it's the same concept. Okay, so if you want to work out A dot B, okay, we take the magnitude of A, which is 5, times it by the magnitude of B, which is 6, okay, and times it by the cos of the angle in between them, which is 120 degrees. So this is the same as 30 times the cosine of 120 degrees. And to work out cos 120 degrees, you have a unit circle with the reference angle of 60 degrees here. And we know that cos is always negative in our second quadrant. So we can say that this is the same as negative cos of 60 degrees. And cos of 60 degrees is simply just a half. So we have negative a half. So times by negative a half. And therefore, A dot B is simply just equal to minus 15. That's how you do this question here. Our next question is this here. We are told that the dot product between vector 1 and vector 2 is equal to negative 6. And we're required to solve for the value of x. So if you want to dot product these two vectors, all we simply have to do is multiply out the I components together and then add it with the multiple of the j components together. So in this case, we'll simply have 5 plus 2x is equal to negative 6. That means 2x equals to negative 11, and hence x is simply equal to negative 11 on 2. Let's have a look at another one. Okay, in this one, we do the same steps. Okay, times the i's together, times the j's together, or the horizontal components and the vertical components. So minus 2x minus 3 equals to x. And this means that minus 3x is equal to 3, and hence x is just equal to minus 1. And the next one is this one here. So we need to dot product these two vectors together. So minus 4 times x plus 7x is equal to 10. And therefore, we can say that 3x is equal to 10, which means that x is simply equal to 10 over 3. And lucky last, we have this vector equation here. We are told, this is meant to be a dot product, not an addition sign. Okay, we're told the dot product between these two vectors is 6. So first thing I'm going to do is I'm just going to expand out this x to this vector just so I have a nice vector equation in component form. So this is 2x and 3x dot producted with 1 and x. And that is equal to 6. So now if I expand this, okay, if we dot product the top and the bottom, we get 2x plus 3x squared is equal to 6. Okay, and if we want to solve for x, we simply have to solve this quadratic. 3x squared plus 2x takes 6 is equal to 0. So in this case, we need to factor out two numbers that multiply to minus 18, but then add to 2. And the two numbers that I can think of here are, which in this case is going to be a bit tricky, so let's just use the quadratic formula. Okay, the quadratic formula, x is equal to minus 2 plus or minus the square root of 4 minus 4 times 3 times minus 6 all over 4, all over 6. So now what we get is minus 2 plus or minus the square root. Let's work out the inside. So we get 4 minus 4 times 3 is 12 times 6 is 72. So this becomes 4 plus 72, which becomes 76 all over 6. We can say that this is factorizable by 4, and you can just do 4 times 19 in this one here. So 4 times 19 works. So that's the same as minus 2 plus or minus 2 square root 19 all over 6, which you can factor as minus 1 plus or minus square root 19 all over 3. So these are your values of x, which makes this dot product equation true. Okay, here's our next question. We are required to work out the angle between these two vectors here. Okay, so again, we know the formula from last time that I taught you, was that two vectors dot producted together is simply equal to the magnitude of both these vectors times by the angle in between. So we can easily work out the magnitude of these two vectors by simply employing Pythagoras. But how do we work out the angle? Well, we can just rearrange our entire equation here for theta. And if we end up doing that, we get theta is equal to cosine inverse of A dot B divided by the magnitude of A times by the magnitude of B. So let us do this first. To work out the angle in between, okay, to work out theta, we simply do the cos inverse of the dot product on the numerator. So let's first work out the dot product of these two vectors. So if we dot product it out, we get 1 and then minus 8, which gives us minus 7. So that's the dot product of both these vectors, divided by the magnitude of both these vectors. The magnitude of the first vector is simply equal to the square root of 1 squared plus 2 squared, which gives us the square root of 5. And then the magnitude of the second vector is simply equal to 1 squared, or the square root of 1 squared, plus negative 4 squared. And that gives us square root 17. So this is the same as this, which we can just write for neatness sake as minus 7 divided by the square root of 85. And if we use our calculator to work this out, we get 139.40 degrees. Now let's have a look at the next one. Okay, pause the video and give it a go first. Work out the angle between these two vectors here. Okay, so again, theta is simply going to equal to cos inverse of the dot product of both of these. So the dot product here would be minus 2 times 2, which is 4, and then plus minus 2, which is just 2, because we're just dot producting them, so that's 2, all over the magnitude of each of these vectors. So the magnitude of the first vector, square root of minus 2 squared, plus 1 squared, that's square root 5, and then square root of minus 2 squared plus minus 2 squared. For this vector, that's just the same as the square root of 8. So again, for neatness sake, that's just cos inverse of 2 over square root 40. Okay, and if we work that out on a calculator, that is 71.57 degrees. Okay, next. Okay, you know the process. Okay, theta is equal to cos inverse of the dot product between the two, and in this case, the dot product is simply 8 plus 0, which is just 8, all over the magnitude of each of these. We know the magnitude of the second vector is simply just 4, because it's only 4 units in the horizontal direction. There is 0 vertical component to this vector. So you can just say 4 times by the magnitude of this vector, which we have to work out. That's the same as 2 squared plus minus 1 squared. So that's just the same as square root 5. And if we work this out on our calculator, that's the same as 26.57 degrees. And lucky last, this vector here. Okay, so theta is equal to cos inverse the angle in between both these vectors, which is minus 7 plus 1, minus 7, and then plus 1. That's the same as minus 6, all over the magnitude of each of these. So the magnitude of the first vector, square root of 7 squared plus 1 squared, that's square root 50, times the magnitude of this, which is just square root of 2. Okay, so that's the same as, for neatness sake, cos inverse minus 6 divided by square root of 100, which is just 10. Okay, so if you work this out, we get 126.87 degrees. And that's how you work out the angle between two vectors.